Hello friends, in this video we'll see how to check beam column capacity ratio or the BCC ratio. Okay, so let us see a small theoretical background before this check. What happens is that at any junction between beam and the column, let us take this junction over here as an example. This column must be stronger than the interconnecting beams. Okay, so why is that? Suppose that if this beam over here fails, then only these two panels will be affected, right? However, if this column over here fails, then the entire floor will collapse and the floors above this floor will also collapse, right? So due to this reason, at any junction, the column must be stronger than the interconnecting beams. Okay, this thing is ensured by the beam column capacity ratio, or called as the BCC ratio, and this factor needs to be checked. All right, so most of the designers just skip this thing. However, this might lead to blunder results when there is a severe earthquake. All right, okay, so for that, what we'll do is we'll click on this drop down menu over here and click on display design info, and after that we click on identify all failures. Okay, and after that we click on OK. So here it's written BCC in every column, so it means that all our columns except this column over here, this tiny column, has failed in BCC. So it means that at this junction the columns are stronger than the beam. Okay, so how it calculates is that it sums the moment of this column at this edge and this edge, and the moment must be greater than or equal to 6/5 times the summation of the moments of the beams at this junction. Okay, if you want to see the BCC value, what you can do, you can click on display design info, and after that click on beam column capacity ratio and click on OK. So this value must be less than 1. You can see that at every column in both directions the value is greater than 1. So 2.377 means it's very much high. 3.910 is very high, right? So here it's 0.517 and 0.918. Due to this reason this column passed, right? So now we'll see how to overcome this failure. All right, there are two ways by which you can overcome this problem. The first is that you can increase the size of your columns. Okay, and for that let's unlock our model and click on OK. So after that, what we do, we go to define and click on section properties and click on frame sections. So after that, what we do, we click on column and click on modify so property, and what we do, we change the size to 350 mm and see if it helps. Okay, so click on OK and click on OK. Again, run the model. And click on design. And after that, click on display design info and click on identify all failures and click on OK. So you can see that so these two columns passed, however all the other columns have failed. Okay, so theoretically what you can do, you can keep on increasing the column size, but practically, so if you do beyond this 350 mm limit, so your sections will be very much uneconomical, right? Okay, so we won't increase the section of the column beyond this, and next solution what we'll do is that we'll increase the reinforcement value. Okay, so for that just unlock this model and click on OK. So after that, go to define section properties, frame sections, and after that click on column and modify so property, and here let's change the size to 12 inches, and here also 12 inches. Okay, and we click on OK, and again we click on OK. So now what we do, again run our analysis and again design. So now what we'll do is that we'll place the reinforcement values that is required by this sectional area. Okay, so let's find number of rebars required to attain this sectional area of reinforcement. Okay, so we'll use Excel for that. So we'll see this thing in very much detail in the later sections of this series, where we'll know how to detail these columns. Okay, so this is just a rough and preliminary thing for right now. Okay, so let's use bar, and here we have to attain 1014 in this B column and 958 here. So 958 and 1014 are pretty much similar. Okay, so we'll use bar, so we'll use 16 mm bar, right? And here number of bars we'll use 4, and here area, so area of total reinforcement is equal to number of bars into area of 1 bar, right? So let's do it, is equal to 4, or we can do this value into, say, pi by 4, right? So 3.1416 divided by 4 into this value square, right? Into this value square, and hit enter. 16 mm bars, 4 in numbers, give this much area. However, we require 1014 to be attained, right? So what we do, we again copy this value and paste it over here. So okay, so let's just do Control V, and we'll use 12 mm bars, 4 in numbers, and let's sum them and click on auto sum. So it's 1256, right? So if we click on 2, how much? 1030, required is 1014. They are very much close, so we'll use 4 number of bars of 12 mm to be on the safer side. Okay, so what we'll do is that we'll place 1, 2, 3 and 4 16 mm bars at the corners, and 1, 2, 3, 4 12 mm bars at the mid portion. Okay, this will do for this column and this column, and for other columns we'll just use 16 mm of bars, 4 in numbers, right? So it will give the area of 804, and the required is only 743. Okay, and here also you can see that it's 743 and it's 1076. The lower value is at the bottom and the higher value is at the top, so we cannot do that. So what we have to do, you have to place 1076 here also, 1076, 799 and 792. So these two columns will have same reinforcement detailings, because 1076 and 1014 are both satisfied by this value. Okay, so these two column grids are presented here as an example, and you have to do same thing for other columns as well. Okay, so now what you have to remember is that 1, 2, 3 and 4 columns have same reinforcement detailings, and other 1, 2, 3 and 4 columns have same reinforcement detailing. Okay, so you remember this thing, right? So we unlock our model and click on OK, and after that go to define and click on section properties and click on frame sections. So here what we'll do, we'll add a copy of property, that is we'll define a new column. After defining a new column, we'll assign this column to these 4 columns, and again we'll define another column and we'll assign that column to 1, 2, 3, 4 columns. Okay, we click on add copy of property, and after that name it as a revised column. You can name whatever you like. Okay, so we'll keep the section dimensions as it is, and what we'll do, we click on modify, so rebar, and here the longitudinal bars, so it's fine. So rectangular ties is fine. So here check design, we'll click on reinforcements to be checked. Okay, so because we have already detailed these bars, and we'll check these bars for BCC failure, that is why we click on this option over here. So clear cover for confinement bars 40 mm is fine. Number of bars along 3 direction face, so it means that we'll have 1, 2, 3, 4 number of bars in 12 mm, so that's fine. So we'll click on 12 mm over here, and corner bars will have 16, right? So total of 8 bars, right? So 1, 2, 3, 4, 5, 6, 7, 8, right? So don't get confused with 3 and 4. Okay, so this is a different thing and 4 is a different thing. Okay, and after that, so confinement bars will keep off 8 mm, and we click on OK, and after that we click on OK. So again what we do, we define columns for these 4 columns, and we click on add copy of property. Alright, so click on modify, so rebar. In this section we will not be placing any mid 12 mm bars, right? So we'll only keep the corner 16 mm bars. So what we do, we click on this drop down menu and click on user. That will give us the number of bars as 0, and we click on OK. So let's change this name, so we'll tell them as revised upper COL columns, and we click on OK, and after that we click on OK. Alright, so after that we select these 2 columns and these 2 columns also, and go to assign, click on frame click on section property, and we assign them as revised column, and we click on OK. So now you can see that, so this is a column and this is also a column, right? So a column means the column having the sectional area and the reinforcement that we defined, right? And these four have now become the revised columns. Okay, and again we select these two columns and these two columns again, and go to assign, click on frame, click on section property, and we click on revise upper columns, and we click on OK. So now what do we do? Okay, so we happen to select this column over here as well. So let's do it, and we'll not focus on this column. Okay, right? So now what we do, we run the analysis. And again we click on design. Here you can see that the reinforcement that is designed by the ETABS is given as a plain number 799, and the reinforcement that we provided and told ETABS to check the reinforcement, so it has placed in the brackets, right? So now what we do, we click on this drop down menu, display design info, and click on OK. So still our upper floor columns have failed, right? Let's do another trial. So in this trial what we will do is that we'll reduce the depth of these beams and see if it helps. Okay, so unlock this model and click on OK. So after that, go to define and click on section properties, frame sections. So beam, we add copy of property, so name it as roof beam. All right, so we'll decrease the depth to 300 mm because on the roof there is not much load. That is why we place 300 mm deep beam at the roof. Okay, and click on modify so rebar, and here the things are fine, right? So we click on OK, and after that we click on OK, and again we click on OK. So after that what we do, we go to the roof. So we are already on the roof. Here you can see roof written, right? So we select the beams over here, select these beams. All these beams will change. Okay, and go to assign and click on frame section property and click on roof beam and click on apply. So now there are all roof beams. So now after that, again we run our analysis. So you see this analysis and design thing takes a lot of time. That is why the video has become very much lengthy. Okay, but you know, these are the things that you should learn and they are nowhere taught else. So click on design. And after that, click on display design info and click on identify all failures and click on OK. So you can see that they have still failed in BCC. So let's check their value. Beam column capacity ratio. So they are pretty much near to 1, right? So now what we'll do is that we'll again unlock our model and increase the reinforcement of these 4 columns. So go to define and click on section properties and click on frame sections. After that, click on revise upper columns and click on modify so property. Okay, so now what we'll do is that we'll place 2 bars here. You can place here also, that's as per your choice, right? So click on modify so rebar, and along 3 direction face we'll have 2 number of bars, right? 2 number of bars of 12 mm. Okay, all right, so we click on OK, and again we click on OK, and after that we click on OK, and again we run our analysis. So after that, design. So you have to keep on doing this hit and trial things. Okay, after that, click on this drop down menu, display design info, and click on OK. So now you can see that these values are lesser than 1, right? So which means that they have passed BCC failure. Okay, so let's click on identify all failures and click on OK. So now you can see that our columns haven't failed in anything. This is how you control your columns for BCC failure, and this is a very important thing that should be checked. All right.